Okay, so welcome, my algebros. No, we're not going to do that. All right. So displacement of a squirrel. Basically, what I wanted to point out here, and I'm just going to do this to set it up, right? Like, you don't have to do this, but in terms of like clarity, this lets me know like what function I'm working with and what part it aligns with, just as a visual, so I can say, we know the names of these types of functions, but it's wow. Someone's excited. Yeah. And that guy there. So, Nolan, when I start something that looks like this, the first thing to identify on it, and the most important part of this question, is if they give you this, you're going to lean on that throughout the whole question. And reason why I say that is we're always asking ourselves, like, number one, like, do I have to find a rule to then use a rule? And then so that's basically it, is that this 2, you can see right here that the first function and the second function both exist where x is 2. So that means right now, I know x is 2, and there's a y value there that I don't know, but I do have that rule. So step 1 is literally just saying y is equal to negative t plus 10, and I'm going to plug in negative 2 plus 10 and get a y value of 8. So this is going to be 2, Morgan, focus, bud, 2 and 8, right? So that's the first handoff point, meaning I can now cross off the first guy and go straight to the next one. Just to identify, what am I looking for in all these ones? This one I'm going to need C to get the rule. That one I'm going to need A. This one I'm going to need K. And this function I'm going to need B. Those are all the missing parts of each of those rules that I'm going to need to find.
What does T stand for?
So T in this case is X.
Okay, is it usually X?
Usually is, but sometimes when it says time in seconds, they'll put T. It's just kind of annoying. If you want to write it out when you answer the question, if you want to change T to X, I have no problem with that.
Okay, so T's kind of confusing.
Yeah, right, because it's just like sometimes a different letter is a different variable or a different parameter, and in this case, it's like, no, that one's an X. So you should be able to identify from the format of it which one, like, so I know here that that's H and that's K. This one, I would say the C over T plus 6 is weird, but that one's it's a rat being hidden, right? Because it doesn't have an H. It's like T minus 0 or X minus 0. So because there's no H value, it looks really, really weird. But anyway, so my second step is I'm going to use that 2 and 8, and I'm going to plug that into this rule. So C over T plus 6, I'm going to plug in 8 is equal to C over 2 plus 6. And that's it. Bring that guy over. 2 is equal to C over 2. Multiply by 2. Multiply by 2. C is equal to 4. So now I have the second rule. So from there, I can go ahead and skip down. Well, I can't skip down yet. I'm going to try and find the next handoff point so that I can then skip down. And so, Nolan, that's the biggest thing that you're going to make a mistake on. People will rush to get to the next one. But I found the rule so that step 3, I can use the rule. In this case, y is equal to 4 over t plus 6. Now I'm looking for what is this x value right here. So y is equal to 4 over 4 plus 6. Because I'm just plugging in that handoff value of x. So y is just going to be 1 plus 6. Y is just going to be 7. That's telling me that it's going to be 4 and 7. So I always like to write it on here just to, like, for my own clarification, that that's what I just found is that point there. Now I'm getting into the next one. The next function is this guy here, that absolute value one. Y is equal to a t minus 6 plus 9. What am I going to do for that guy? Use the point that I just found. So this 4 and 7 gets dropped down right into here. 4 minus 6 plus 9. So that's all this is here. We just now rearrange and solve for the a. The only thing that's weird about this guy is, so negative 2 is equal to a, and then I have negative 2 in the brackets. If you forget, whenever I get to this stage and I've isolated for a number and then a times absolute value bars, if I want to get rid of those absolute value, I'm just going to turn it positive and use regular brackets, and that's it. So then now I can, okay, now I can just divide by 2, a is equal to negative 1. And I'm going to double check by looking at the diagram. Does it make sense that an absolute value function that's facing upside down is negative? And yes, it does.
Why does it like change from negative to positive?
So as soon as I execute, like if I have a value inside it, those bars are saying, if, like they're basically just saying, if you want to know the absolute value of this, it's just what's the number? What's the actual number? Not the sign. It doesn't, if it was a positive 2 and it has the absolute value bars, it's still a positive 2. So it's really just asking, like, what is the numerical value? The sign we ignore, and we do that. In order to get rid of it, we'll just rewrite it as a positive value with regular brackets. Yeah. So it's just basically saying at that point, once I've broke it down into that, I can turn this into that. Is essentially it. So now I'm going to go back up and look at what's my next handoff point, 9. So step 5 is going to be using the function that we just found. So negative 1, negative t minus 6 plus 9. And what did I say it was? 9. Y is equal to negative 9 minus 6 plus 9. So y is equal to negative 3. So here, I'll show you these bars again. Now that I've got a value in that, the next step would be negative 3. It was positive, it stays positive, that's fine. Now negative 3 plus 9, y is equal to 6. So I didn't just find y is equal to 6, I found when x was 9, y is 6. Now I can go into the next guy because I've got 9 and 6. So I'll go and take the square root function now and try and find k. And actually, this is one of those interesting ones there. What did they just tell me? And I'll write it down. So 6, y is equal to 3, x minus 9 plus k. Y is it 3? Okay. If I have y is equal to 3 square root of x minus 9 plus k, and I just found out that that's the next handoff point, what did that just tell me? I'm going to draw your attention to this. That's the h and the k. Because the 9 right here exists, right? Well, this is telling me that the h of this guy is 9. I know vertexes exist, like whatever the x value is, the h goes along with it. So that means I don't need to do any mathing at all. No mathing. Just straight up x minus 9 plus 6. Because it's telling me what the h and k is by writing it down right there. So it's kind of hidden in plain sight. That's where a lot of people will freeze.
You know how last year was like you could like see the H and K were like on the
Yeah.
tablets? Is it the same this year? Like, is there a way to tell for each?
No. So, well, on the question I think I've given you, you will see it will be labeled. Like on the diagram, if that handoff point is an H and K, it will identify it on the diagram. It'll say, so it's not on this question here, but on like the test one and other test examples that I've seen, you'll sometimes see that if it is the H and K, they'll either write it out in the text or on the diagram, point itself will be like h1, k1. Like they'll label them for like which function it goes with, or which piece of the function it goes with. So that one's pretty easy. I didn't need to do much work. Now I can literally just plug in. I have the rule of it. So what's the handoff point? 13. So I can just plug in y3, 13 minus 9 plus 6, and solve. Y is equal to 3 times 2 plus 6. Y is equal to 6 plus 6. Y is equal to 12. So that's just me executing. This would be step 7, let's just say, because I'm plugging in a value to get it. So now, when all this is said and done, the last step, if I go back up, what the heck did I need to find? Well, I still need to find after how many seconds does the squirrel touch the ground. So I'm still looking for the x-intercept, but if I go back up to my diagram, let me close these guys out. I think they're slowing things down.
So with these ones, there can only be like an absolute value or a square root formula you can use.
Say that again?
With these ones here, where it's like a squiggly line, you can only use a square root absolute value formula.
Yeah, like they'll use sometimes they'll sometimes use the old school parabola.
Okay, like the.
Yeah, just like a basic AHK with the. Why can I not get rid of this thing? Go away. There, X. Okay. So if I go back up here again, I still need to find this last rule. And if I look at the diagram itself, that's what it's saying I need to find, the x-intercept. So we need that last rule. So at the end of it all, I just found out that when x is 13, the y is 12. So I am going to plug that in to the last function, which, what was it? Negative 4t plus b. So y is equal to negative 4t plus b. Now on this guy here, I can plug in that last point that I just found. So 12 is equal to negative 4 times 13 plus b, just to go ahead and get what that guy is. 2652. Yeah. 12 is equal to negative 52 plus b. Bring that guy over. 64 is equal to b. So now the rule for this guy is negative 4t plus, straight up better, plus 64. So at this stage of the game, I can go ahead and I know that I'm looking for the x-intercept of this rule. So the last and final step here would be to plug in number 9. Let's find the x-intercept. Oh, please work. There we go. And then set y equal to 0. So that's the only one that's different, is that everything else I've been solving for is y when x is something. Now the last step is, what is t when the y is 0? Plus 64. Bring that over. Negative 64 is equal to negative 4t. Divide by negative 4, divide by negative 4.
When you say 4t, it sounds like 4.
Yeah, 4t, 4d. So I would change it to x for you if you wanted to. So then the time is 16. So that's finito. But again, just to reiterate, like we had to work our way through all of the functions just to get down to that last step to plug it in. Yeah.